Hi, my name is Melissa Hunter. I'm a systems engineer here at NXP Semiconductor. In this video, I'm going to go over some key hardware design tips to help make your very first board design successful. The first tip for a successful board design using the RT processor is to use our existing EVK design as a reference while you're doing your own board. Here on nxp.com, this is the webpage for the RT 1050 EVK, and down in the documents section we have the printed circuit board schematic section. You can find all of the design files for the board, so you can use this as a starting point or at least a reference for your own design. Next, we're going to take a look at several different aspects of an RT board design, starting with the power supplies. The processor does include an on-chip DC-DC as well as several integrated LDO regulators. The combination of all of these allow you to power the entire processor off of a single 3.3 volt supply. We also have a USB regulator, which would be powered from an optional VBus 5 volt supply. You could also have a secondary 3.3 volt nominal supply from coin cell or other battery, which would power our SNVS domain, which is equivalent to a VBAT type domain. And then we have several I/O domains you could optionally power at 1.8 volts with an additional supply. The I/O domains are all separate, so you can mix and match 1.8 volt and 3.3 volt I/Os as needed for your system. Next, let's take a look at boot modes and boot configuration. The processor supports 3 different boot modes, which are controlled using 2 boot mode select pins. During your prototype phase, we strongly recommend that you have switches or jumpers or some other means of selecting the boot mode on your board. While debugging, it can be extremely useful to have a means of forcing the board to go into serial downloader mode. Once you are ready for your production phase, you may decide to eliminate these switches or jumpers, but at least for prototype phase, we highly recommend including them. This is the boot mode and boot configuration selection circuit used on the 1050 EVK. You can see here we have switches that allow you to select a number of options for the boot mode pins here, and then there are also 12 different boot configuration pins. The boot configuration pins are used to configure your boot device so that the ROM has enough information in order to perform basic access to the memory, which can then be reconfigured later. You can use GPIOs here or fuses to configure your boot configurations. During prototypes, you may prefer using the switches instead of the fuses, as it makes it much easier to experiment with the settings, determine what final configuration you want. Then in production, you can move to using fuses instead for the configuration. Another thing to be careful with when you're using the GPIO overrides, these are sampled at reset. You want to make sure that the circuits that you're using on these pins during regular runtime don't interfere with the boot configuration option. For example, if you're using any of these pins as an I2C, you may have pull-ups enabled on the pins that could potentially conflict with the boot configuration selection. So that is something to look out for in your design. The ROM serial downloader mode is a special mode where execution stays within the ROM and you can then send commands directly to the ROM, which can be used for provisioning of fuses and or loading of applications into external memory. Serial downloader mode communicates over the USB 1 port or LPUART1. We recommend that you have at least one of these ports accessible on your board. Another thing to be aware of when designing an RT board are DQS pins. Both FlexBy interfaces and the SEMC include DQS pins. These are used for timing of read data sampling, and they're required in order to reach the maximum frequencies for both of these external memory interfaces. When you're designing your board, you should make sure that you leave these pins unallocated for other purposes. You're going to want to assign them to their DQS functions, and then you would leave them floating on your board. The exception would be if you are using a memory on the FlexBuy interface where the memory actually provides a DQS input to the processor. In that case, you would connect your DQS to the memory. And as a final tip for your RT board design, make sure that you refer to the hardware design user guides that are available on NXP.com. These guides are full of useful information for designing RT-based hardware. Thanks for watching this video. For more information, please visit NXP.com.